healthier future and give us new ways. For generations, healthcare pioneers have given their lives to one fight: understanding and treating disease. They carry a vision for a healthier future and give us new ways to see it. First, the structure of life was revealed. Then, the function, how cells interact. Lungs expand, signals fire. Life witnessed in real time. It once took years to decode this blueprint of life. Now it takes mere minutes to find a genetic clue. Today, we are recomputing the limits of healthcare with AI. Computers that understand the language of biology, learn from centuries of science to create digital labs. Simulations design new medicines, atom by atom, showing us how to make and test them. Scientists, AI agents, and robots are connected at the speed of innovation. So a breakthrough by one forms a new foundation for all. And AI works side by side with doctors and nurses 24/7, enhancing what they can see, lending an extra pair of hands side by side with doctors and extending what the human body is capable of, enhancing what they can see. This isn't human versus machine. An extra pair of hands. It's building upon the vision of our pioneers to create new possibilities for everyone.
We got to also get a big, amazing chunk of our creative team and our marketing team and so many of the pioneers in this room to make that amazing video. So for the pioneers who are here in the room with us, for those that are watching around the world, thank you. Every single line of code, every single trial we run, and every late night in the lab is for all of us to have this single human goal, giving us more time and healthier time. And so here at GTC, it's our job to help take the most incredible technological breakthroughs of our lifetime and put it in the context of healthcare so that you pioneers in this audience can rip them out of our hands and put them into some amazing life sciences and healthcare applications. And we're going to see so many of them today. I hope I can squeeze it in the 45 minutes they've allotted, but there's so much to talk about. As you know, we are at this incredible moment in time, experience agentic AI inflection points just moment after moment. The minute you think you've grokked language models, we've moved into agents. The minute we thought we knew agents, agents are now orchestrating other agents. What is so awesome about this particular technology is that the way it's architected is a complete new way of developing software. And it's opened the possibilities for it to be trusted and applied into healthcare from almost day one. This is unlike many other technologies. It still takes incredible might for us to understand the technology, to ground it in the knowledge that is so deeply embedded and domain specific, to take advantage of some of the most important technological breakthroughs of agents, which is building them into things that can use other tools. This ability to use other tools and interact with older, antiquated systems of the healthcare industry is a huge, huge advantage for us to be able to take software like this, software in healthcare that used to be otherwise monolithic, and now break it into these specialized components And really, healthcare is going to become quite a mosaic of applications. And I'm going to show you how that's actually happening today and in very real time. In order to take advantage of this in the healthcare industry, some of what we need to have is models and open models. Why do we need open models? Well, there's a huge basis of information in the world that you need to lay into the foundation of these models, and then you need to domain customize them. If every single healthcare company tried to make their own foundation models for the ground up, we just wouldn't have enough time or money or capital investment in order to do so. And so companies like NVIDIA are one of the most contributors to AI open source, not only models, but we have over 650, probably close to 700 open models now available. But we surround these models with so much more tools and data in order to help you. Now, we build foundational models in a couple very core areas that actually, if you think about healthcare, is a superset of so many applications. So on the left-hand side, you can see we have Nemotron for language models and agents. We have Earth-2, but it's really about physics. There's so much about what happens that is based in physics that we do in healthcare. BioNemo for biology AI, we've been building for quite some time. And on the other side of this, you see the physical AI world, which we're going to talk about a lot today because there is so much we can do in healthcare, yes, in silico, but there's absolutely a ton that must happen in the physical world. So we have Cosmos, that is our world foundation models. We have Groot, which is our robot brain models that are generalized but then can be specialized for domain-specific applications. And of course, Alpamayo, the automotive industry and self-driving cars, which has helped us learn a lot about how we can apply automation into some of the critical areas of healthcare like surgical robotics. And so as I said, AI is not just a model alone, especially when it comes to deploying it into regulated environments like we have. Or I think you hear from a lot of our speakers today that just like all of you go into medicine and then you deeply specialize, or you go into science and you deeply specialize, all of these models also need to be specialized. So we create these amazing models where we pour deep amounts of investment and we open source them to you along with their data and all of the tools so that you can customize them in really, really exquisite ways. So you can get that specialization, you can look for all those cost optimizations. There's a lot of ability to look at high system accuracy across this. And we need to have transparency and control in a lot of our industries. And of course, in a lot of ways, these need to be sovereign, whether that's a large pharmaceutical company that wants to remain all of their data as their IP in sovereign, or it could be at a national level. And so Jensen kind of talked to you about this, and Carrie Brisky, you can go see her talk as well. Our NVIDIA Agent Toolkit in our Nemotron open models is a full AI lifecycle for agentic AI, complete end-to-end. It really starts, of course, with the data. You're going to see this pattern repeat itself for all of our open models, where it starts with the data. Yes, you can curate real-world data, but there's also a gigantic need for synthetic data, no matter what application space you're in. Jensen and the team have announced a barrage of amazing new models. We started Nemotron Nano, which a lot of the companies are using, but we just announced Super and Ultra. These open models have now reached the frontier in multimodal AI language models. We have easy ways for you to customize it. We have amazing ways now for you to take these models, or it could be at a national level. And so Jensen kind of talked to you about this, and Carrie Brisky, you can go see her talk as well. Our NVIDIA Agent Toolkit in our Nemotron open models is a full AI lifecycle for agentic AI, complete end-to-end. It really starts, of course, with the data. You're going to see this pattern repeat itself for all of our open models, where it starts with the data. Yes, you can curate real-world data, but there's also a gigantic need for synthetic data, no matter what application space you're in. Jensen and the team have announced a barrage of amazing new models. We started Nemotron Nano, which a lot of the companies are using, but we just announced Super and Ultra. These open models have now reached the frontier in multimodal AI language models. We have easy ways for you to customize it. We have amazing ways now for you to take models and go put them in the gym. Make them work out and really start to specialize on skills. And of course, we create these things called blueprints, which are essentially reference applications of how do you assemble
Hmm.
these things in to do work. One of those is called IQ, where imagine if you want to take your whole company's data sources and expose it to an agent that you can now do deep research against all of that information. So just like you can do deep research now in some of the open models, but you wanted to do it on your proprietary data. So we created a blueprint for that. And so all of these tools here really have laid the foundation for this agentic digital health revolution. We're delighted to work with some of the most amazing companies in this space. As you know, we have the NVIDIA Inception program. It's now bloomed to over 5,000 companies. Over 2,000 of those are in digital health. 85% of AI revenues in healthcare are flowing into the startup companies because they're completely thinking outside the box and solving some of the world's hardest problems. And they're doing it at amazing scale. So we're working with Heidi Health. They are a multilingual clinical documentation platform. They're working on 2.4 million conversations a week and doing that across 190 countries. Open evidence, Daniel will be here right after me. They're now used by approximately 50% of the US clinicians in just a matter of 12 to 18 months for essentially, medical knowledge synthesis and putting consultations into medical doctors' context using trusted medical knowledge, taking that and having a real-time corpus of medical knowledge because it's changing all the time right into the hands of the doctors. And Sword Health is also in the booth here and on the exhibit floor, an amazing AI care company. NVIDIA is actually a customer of Sword Health for physical therapy. So they have over 700,000 members that they're treating all the time and over 10 million sessions. And just last month, they recently released their new mental health platform. So these platforms are able to be deployed in such a way like when you download Uber or another application to your phone. They're easy to install, they're easy to understand how to use, right? So you have no barrier to entry from that, and they have an amazing way to scale because of how they're architected. And so they're using NVIDIA's agent toolkit, customizing them, domain specializing them, and then we work with every single one of them to cost optimize. I don't know if you remember seeing Jensen there holding his arms up as the inference king. NVIDIA absolutely focuses so much on inference because just like he said, that round robin on that agent diagram, every single one of those things is inferencing, and it's multi-turn now, and then it's multi-system agents. So inferencing is a super hard problem to solve, and we are deeply, deeply focused on it. And we work with all these companies so they can benefit from the amazing capabilities of these systems, but in a way for the adoption to go through the roof and that our health system can really tolerate. We've been working with IQVIA for some time now, and they just announced IQVIA.ai here at GTC. This is their unified agent platform. It's taking all sorts of the NVIDIA agent toolkit, integrating it into a platform, of course using LangChain, as many of you here in this room I'm sure are, to rapidly build out agents, 150 agents across all sorts of different workflows. They've got deep, deep data sources and a data network that they've been building for decades. They have deep domain expertise in clinical research, and they're essentially building those and specializing agents to do everything from data review or field companion for pharmaceutical sales reps to have very different and meaningful conversations, or literature reviews for all sorts of things that need to happen in the regulatory environment. And one use case I love is around clinical trial site selection. They're trying to find all the right sites, and it used to take many, many weeks to do this kind of work, and now they're shrinking that into days. And every single day a clinical trial isn't delayed is literally money on the table, millions of dollars of money on the table. So IQVIA.ai, their new unified agentic AI platform, and it's built like this. This is how, as Jensen was saying, software as a service and then agentic as a service platforms are being made here in real time. And this is the future of the global healthcare infrastructure. Again, it's no longer this sort of monolithic application that takes many years to install. It's going to be a mosaic of applications, ones with deep specialization, with exquisite and unique ways to operate. And it's tackling literally end to end, from a moment a patient steps in the door or even calls in to try to navigate or receive help, all the way to improving a patient and clinician's experience, to the back office workflow, all the way through to some of those clinical intelligence applications we were talking about a moment ago. And then when you leave the hospital, how do we make sure care continues in amazing, meaningful ways? So, digital health agent boom is here, and agentic AI is, as you could imagine, finding its way into all sorts of places. Let's see how it's creating a new paradigm in science.
Scientific research is expensive and time-consuming. Reading papers, running analyses, testing hypotheses. Edison Scientific is building Cosmos, an AI scientist that can compress a 6-month research cycle into 1 day. Cosmos is not a single model. It's a coordinated system of agents running on NVIDIA's AI models, compute, and CUDA libraries. Customized open-source Nematron models handle specialized tasks, while cloud models provide general intelligence. It starts with a prompt to see how small genetic changes in the brain might lead to Alzheimer's. The Edison Literature Agent uses Nematron Parse to scan millions of peer-reviewed papers, patents, and clinical trial records, separating text, figures, and formulas. From there, frontier models can extract insights from decades of Alzheimer's research. The Edison Analysis Agent processes large-scale biological data, accelerated by CUDA libraries, cuML and cuDF, and interpreted by Nematron to identify statistically significant genetic patterns linked to cell loss. And finally, the Edison Molecules Agent uses a model trained with NVIDIA NeMo RL to reason over chemical structures and propose molecules that help prevent cell loss. Edison is advancing the search to cure diseases like Alzheimer's and accelerating the pace of discovery across every domain of science.
Incredible. Is the Edison team here? Did you guys make it here? I don't know if they made it here. Okay, great. Good to see you, Sam. Awesome. Guys, it's just wildly incredible what we're about to do for science. If you just saw that, 6 months of work compressed into essentially a day, we are going to create an amazing additional challenge. Once we have all these amazing scientific ideas, the next thing we have to do
Holy
is try to
fucking
test
shit,
them.
man.
And there's 2 ways you're going to test ideas in the future. You're going to test them in a digital dry lab, I like to call it, and then you'll go test it in the real world, in a life sciences lab. Okay, so life sciences overall is a several trillion-dollar industry, and you're seeing it take a very different shape here with amazing technology. So you just saw Edison and their AI scientist. And that scientist is going to go clue into a digital AI factory for doing drug discovery, where we're going to talk a lot about our efforts in BioNemo, and then we're going to talk a little bit about what's happening in lab automation. So we are entering the era of reasoning models in biology. We're now essentially in our third generation. It's oddly kind of following a similar pattern to GPT. It was in the GPT 3, 3.5 to 4, where things in reasoning really started to take shape in the area of language models, and we've now gotten to that era. First, it was structure prediction. Second was really de novo design. And now we're into this sort of interaction design phase, and we're going to talk a lot about reasoning, and it's a really exciting time. And one of the things in all industries, in fact, that holds AI back is data. And so if you remember the AlphaFold moment, an exceptionally AlphaFold tool that won the Nobel Prize, really, because it reached experimental accuracy in its predictions. When you have a model that is able to reach experimental accuracy, you can turn that model into a data generator, right? And so first you need the real world data, and it was 50 years of experimentation to build these databases like the protein database. And it allowed for AlphaFold 2 to be born. And then once AlphaFold 2 was born, it was able to be used in inferencing and synthetically generate 200 million versus the 200,000 protein structures that existed. And that gave way to all of those models that you just saw on that previous slide. And so this concept, Jensen talked to you a little bit about it, but I think this really puts it into context, is compute is data. As these models improve in accuracy and capability, you can use them to generate data and to go post-train models for all sorts of different tasks. And I just showed you how you could do that with AlphaFold 2, and Google DeepMind team did just that. And so we've been working on this problem for a long time, recognizing that it was still pretty computationally expensive to run AlphaFold 2. And so over the last couple of years, we've been working on some really critical libraries. Q-equivariance that Jensen mentioned is now under the hood of every protein model out there. So these models understand 3D geometry. We worked on GPU MSA. So the MSA was on the CPU, and it was that huge bottleneck of AlphaFold. We moved all that to the GPU. And then thirdly, of course, all of our inferencing, which is the AI part of AlphaFold 2, and we made that as fast as humanly possible. So about 100x or more speed up. Now that we've been able to add that speed up, we can imagine using this model to generate even more complex data sets. And so we're super excited to be announcing a new AlphaFold protein complexes data set that is available for you and announced here at GTC. We worked with EMBL-EBI, with Google DeepMind, and with Seoul National University to create this amazing data set of 30 million protein complexes ready for download. And the EMBL team is making these exquisite, very high quality, 1.7 of these available on their website of interactive structures. And so imagine these are complexes. The previous generation was really single molecule, monomer proteins. We're now doing complexes, which required essentially 100 times more compute for us to be able to predict these structures. And so it's just really, really beautiful what we can now do with such a large data set, and we're so happy that it's available for you. We can imagine continuing on this reasoning journey. We're also announcing today a new model in our Proteina family. This is our third generation called Proteina Complexa. This is a protein design reasoning model. If you look at the inputs of this model, it takes in a target, its hotspots, and then some design parameters, how you want it to search, how many designs do you want, and essentially under the hood, the AI generates a rough draft of the protein, and then it uses this built-in scoring system to constantly test it and refine it. And it keeps tweaking it until the design finds this perfect structure that obeys the laws of physics down to the atomic level. And so if you think about what's going on here, We're giving this model the ability to think. And this is a process that you've probably heard, which is test time compute. So just like us, when you kind of give us some time to go off and think a little bit longer, we generally come up with some better ideas. And so essentially, the more compute you have, you can expand the number of designs. And this protein complexa is actually extremely efficient. If you look at the previous model in this class, we're able to essentially compute twice the number of binders in the same computational footprint. So Proteina Complexa, as the checkpoints are available to you and how it was built completely. We've worked with some amazing partners to not only that, it's so amazing and good that we worked with a bunch of great partners to do experimental validation.
Good.
Just how good is this model? And so you can see that there's amazing validation here. So it's been rigorously tested. So on the right with over 1 million binders that were tested. The Viva team successfully generated 16 binders for a very challenging target associated with a muscle wasting disorder. And for the first time, the University of Cambridge has the first computational design of a protein capable of binding to a carbohydrate antigen. All of these amazing results are in the paper, and it's just amazing to see how what we can do in silico is adding a lot more ideas and binders and designs by using some of the latest reasoning and test time compute capabilities. So we are squarely in the reasoning era of biology. What we need to then think about is compute, right? There's three challenges in AI. It's data, the algorithms, and then compute. One of the things we really needed to help the world unlock was the ability to compute larger and larger proteins. And so we worked on this framework called context parallelism. And this ability to essentially unlock the context window of what we can predict. So it shards these massive molecular complexes across GPUs, so you literally have unlimited ability, unlimited context window. And before, we were limited to a single GPU. So some of these proteins we were looking to explore, we just couldn't do it in a computer. It couldn't happen. Now we have literally unlimited, and we worked with an awesome set, again, of great researchers out there who are doing real work in the design, and they're testing it in their models with really, really incredible results. So we, again, package all of these amazing breakthroughs, whether it's data or awesome models or techniques like context parallelism or the really efficient inferencing of the best canonical models that are being put in production, all the way through to thinking about brand new ways that we're going to build analysis pipelines now that we can do things on timescales we never imagined in our blueprints. And so NVIDIA BioNeMo is just expanding immensely. We're growing our team. We are working with amazing partners around the world so that this digital dry lab, I like to call it, is getting more and more capable by the day. And as you heard Jensen today talk about AI factories, you're going to need BioNeMo and everything that it's doing and all of the data that we're going to be able to generate, all of the scientific ideas that we're going to be able to generate with AI scientists. We're going to need AI factories across life sciences. This is fundamentally changing the R&D process. What's also super important is all of these great ideas that are done in a computer have to make their way to the real world. So we have a bottleneck we need to be really cognizant of in the lab. And so lab automation is become a very hot topic. I saw some of my Thermo Fisher friends in here. And this is where agentic AI meets physical AI. We need to have spatial understanding. We need to have reasoning and planning. We need to have physical execution. And a lot of what you saw in the physical AI of Jensen's address is completely applicable here. We're working with some really great companies in this space as well, building on NVIDIA. So high-res is really using perception in really powerful ways to allow for it to adapt to the environment. So it's using sort of outside in to increase its precision in the lab and do really, really domain-specific, exquisite work and adapt to all different lab environments. TCAN is building an amazing orchestration engine using Nemotron, taking all the inputs of the lab to understand and better operate the lab, more efficiency. Really amazing. And then you have the third component is you actually need to act in the lab. And so in order to act, you want to build that vision language action model brain. You need the brains of the robots to understand the context around that it's working and be able to adapt in these environments. So OpenTrons has joined us here also at GTC. They have a really great demo in the booth, and then there are over tens of thousands of instruments out there using all of this technology to build more and more intelligence into lab automation and extend every single benchtop lab all the way through to how do you exquisitely automate it across the entire process. So this is the next wave of the wet lab as well. With all of these incredible breakthroughs, as I said, we are fundamentally shifting the traditional R&D and how it was done to something that is completely AI native, through and through. Whether it's how you do your science, or how you want to simulate molecules, or how you want to test molecules, AI is throughout. And so AI factories are absolutely essential. And we're really excited to be announcing, where's the Roche team? I know you're here, the lights are bright. Hi guys, wonderful to see you. They are scaling their NVIDIA AI factories to accelerate therapeutics and diagnostics development. Exactly why? Because all of we talked about. Roche is tripling their AI factory footprint to reach over 3,500 NVIDIA Blackwells across the US and European sites. AI is now fundamentally embedded in Genentech's lab in the loop. And all of their strategy is we're leveraging BioNeMo, we're working with them to optimize all of their AI model designs so they can put them into production at very high throughput. Roche's manufacturing divisions leveraging NVIDIA Omniverse libraries so that they can build high fidelity digital twins so they can practice and optimize before manufacturing sites are even stood up. Their amazing diagnostics business, which we've been working with for a long time. I see Chuck, my longtime friend here, is using NVIDIA Parabricks and all of our accelerated computing platforms to build some amazing new diagnostic platforms and do these amazingly large genomics analysis workloads. And so Roche team, very excited to extend our long collaboration and what we announced at, I think it was 2023 GTC with Genentech, and now you see it's completely infiltrated the entire Roche enterprise, and it's amazing, and we can't wait to continue working with you and see what you do. All right, we're going to move into healthcare for this last section. We need to scale global healthcare with physical AI. Just like I said, we're going to generate all these amazing ideas, but where the rubber hits the road is in the physical world. And when we think about, again, the idea of training robots, one of the biggest challenges is data. Even real-world data is very, very hard to come by. And then if you think about just the insane amount of permutations in the world for any one robot to operate, 160,000 unique and different looking hospitals. You have every operating room looks different. You have 72,000 medical procedures. I looked that up. I didn't even know there was that many. You have how many medical devices that are part of those medical procedures. So just the permutations here are just enormous and almost feel impossible. And so we see a future where there's going to be at least 3 classes of robots that we see really coming into fruition to drive this revolution. One is infrastructure as a robot. Think about, I've said it before, your hospital's going to become a robot, right? It's going to have to understand everything that's happening within it, right? The second type of robot are going to be kind of your service and delivery robots, the ones that are really taking action inside the hospital to get true work done. And then the third is kind of going to be these clinical, domain specialized assisted robots that are going to help do some really exquisite augmentation, which we need. And as we know, lots of the world doesn't even have access to surgery or surgeons. And so how do we extend that to even more parts of the world? We're going to need to do that. So you can see there's really 3 layers. I want to start with one. around Project Rio. So the NVIDIA team, our digital devices team, has built out with amazing partners, Paratos, Advent Health, and Lightwheel, really this expression of a blueprint for hospital automation. So it really explains how first you can build your hospital digital twin that you're going to need. Once you have that twin, you can start collecting data, but you can also start generating a ton of data. And then you can start to train policies for all different type of robots to learn in. You've got to create the brain. That brain could be a hospital brain, as I said, a service delivery robot brain, or a clinical brain. So let me put Rio into action for you.
Hospitals today are facing chronic staff shortages. In the future, robots will work seamlessly alongside doctors and nurses to improve capacity and outcomes. But before they can assist, the hospital itself must become trainable. Project Rio is a blueprint for smart hospital automation and physical AI development. First, NUREC and Isaac Sim reconstruct the hospital as a physics-accurate simulation-ready digital twin. Skills are then captured through teleoperation and real-world data. Next, MinICGen scales the collected data to massively expand the training set. Simultaneously, Cosmos Transfer randomizes layouts, lighting, and object placement. Photorealistic domain transfer bridges the gap, ensuring sim-to-real alignment. Inside Isaac Lab, robots train using imitation and reinforcement learning with Groot, helping them generalize skills into real-world behavior. Thousands of parallel experiments run simultaneously,
Fucking
optimizing
shit, man.
policies for precision, timing, and safety. Edge cases are introduced. Environmental variation is simulated. Once validated in simulation, policy moves to hardware. By the time a robot enters the hospital, it is already operated there, extensively in simulation. Together with Paratos AI, Lightwheel, and Advent Health, Project Rio is already powering smart hospital environments today. Hospitals tirelessly generate real-world experience. Project Rio transforms it into deployable intelligence.
Amazing. Great job, guys. I see the Paratos team here. So that technology that you just saw is actually being deployed at Advent Health. It's entering the real world very quickly here because we have these advanced workflows and tools. Today, we are announcing yet another very important data set. It's the world's first and largest data set for surgical robotics. We had the pleasure of working with an amazing contribution of collaborators of over 35 globally to create this data set that for the first time exists. Let me explain OpenH. OpenH is over 750 hours of surgical video and kinematics paired together. This data has 11 different embodiments, and this data has allowed us to do some amazing things that I'm going to share with you. And it's the first one of its kind, and I think there's so many that contributed to it. But of course, we had CMR Surgical, Moon Surgical, Johns Hopkins University, and so many others, and we deeply appreciate it. And we love that we can be sort of this aggregator that can bring the world together, build such a powerful data set for us to see the amazing things that it will do. So once you have data, right, that is the very first challenge, and this is an amazing data set. The next thing you want to do is you want to train a brain. Okay, and so we
Advent
call
Health.
our brain, our robot brain models, Groot H. I call it that because it allows you to have an easy visual with all of our product names. And so Groot H is the first generalizable vision language action model,
Wow.
action model for surgical robotics. So what it takes in is it takes in an image, and then you give it a language prompt, and then it essentially outputs the action. Okay, and this is an amazing first of its kind model that we have essentially post-trained in NVIDIA's, our leaderboard Groot model, post-train that for surgical robotics. And so the dash H is for healthcare. Again, all of these things completely open for you to take advantage of. And then next, because we have 750 hours, kind of sounds like a lot because it was more than the 2 or 3 hours that existed in the world, but it's still not enough to deal with that complexity that I described of 160,000 different hospitals and rooms. And so we also created a huge family of technology called Cosmos H. So Cosmos for NVIDIA is our world foundation models. It helps models understand the context. And so these are world foundation models for surgical data generation, specifically surgical. As you know, trying to write code about the deformation of anatomy and all of that's been a decades-long challenge. And here we're kind of trying to break down those barriers. So first is Cosmos H surgical transfer. And what does that mean? It essentially means that you're
Okay, I
taking
see.
a skill and you're going to practice it in a whole bunch of different environments. So one skill, many environments. That's one data set. Another
handle the
data
fuck
set is you want to predict the next
Video.
action something might take. So I want to have many skills practice in just a single environment. Then you can take those data sets, go enhance your Groot H brain model because now it can learn from a whole bunch of different scenarios it's never seen before. You're introducing edge cases, you're introducing smoke, you're introducing all the stuff that happens during surgery so the model can get better and better and better. You're teaching it more and more skills. And then we have this other amazing model, it's really the first of its kind, called Surgical Simulator. So in silico now, you can take all those many skills and all of those many environments and really evaluate the robotic policy and do that all in silico before it ever gets deployed to the real world. So again, you see how when we put this all together, we've essentially assembled the first and only physical AI end-to-end platform for healthcare robotics, domain specific. So we're taking the amazing breakthroughs of self-driving cars, we're taking the amazing breakthroughs of generalized robotics, and we're helping specialize it, create all the recipes, the data, the starter models for you all to take them and really, really push the frontier of what's going to happen in healthcare robotics. And as I say, healthcare robotics is going to take all shapes and forms. So we put this together. You can find all of this on GitHub and Hugging Face. We publish all of the recipes. We have a developer day on Thursday. I know a lot of you are going to attend. And so hopefully we can continue to, again, expand, and give you what you need. And as I said, the amount of robotics that healthcare robotics encompasses, it is the hospitals themselves. The rooms become robots. You have surgical robots, imaging robots, nursing robots, caretaker robots. We're going to see robots of all time, of all kinds, so that we can, one, allow for all of our healthcare professionals to not have to do some of the things that aren't at the top of their license and free them up for all of that. And we're gonna change patient experience in very, very material ways. And so with that, we're scaling healthcare with AI. We all want to increase access. We all want to improve care. We all want to be armed with the information that's needed at the time when it's needed. And this is an exquisite time to do so.
They are not. Abda.
Thank you so much, Jensen. So we are in the middle of a massive AI revolution. It is probably bigger and faster than even the Industrial Revolution. And you have called out what's happening right now as the largest infrastructure build-out in human history. At the center of that build-out is the AI factory. And the company enabling all of that is NVIDIA. Can you tell us what is an AI factory and why is it the best investment for any enterprise in the next decade?
Okay, so you could understand AI in a particular number of ways. The way that you understand AI probably most is through a chatbot, through a web browser. You're interacting with it. You give it a prompt. It says something back to you. And even those of you who have been using AI for some time, you've seen in the last couple 2-3 years a very significant evolution, improvement in the capabilities of AI. 2 years ago, you heard about GPT. And ChatGPT basically is a computer software that understands the input you give it. It can perceive, understand information, and it can translate and generate the information into something else. Okay, so you can give it a prompt and you can say, here's this PDF I gave you. I would like you now to summarize it. It went from text to text. You could also tell it, here's a PDF I gave you. I would like you to now generate an image of that story. It goes text to image. You could go from image to text, meaning you could give it a picture and you can, what's happening inside this picture? It goes text, image to text. Does that make sense? Anything to anything else. And AI in 2 years, 2 years ago, was largely able to do this translation. We call it generation, generative models, okay? Generative AI. But the thing that is very big deal inside that word generative AI is in order to do something even more valuable than generation, understanding and generating is thinking. Well, you can't think if you don't generate words. And so the foundation of generative AI gave us the ability to generate internal thoughts, thinking, reasoning, step-by-step reasoning, problem solving. It also allowed us to do another thing that is now very important, which is generate intelligence to control something else, to generate control to use a tool. Does it make sense? To use a browser, use a spreadsheet, use Photoshop, use PowerPoint, use something, use AutoCAD, use another tool. Now, that tool today is digital, but someday that tool will be mechanical. So if I generate a command to a mechanical system, that would be called robotics. If I generate commands for a machine with steering wheel, that would be called self-driving cars. Does that make sense? Okay. And so 2 years ago, in fact, you saw the foundations, we call it ChatGPT, and everybody said, it's fun, it's silly, or it produced a whole bunch of crazy hallucinated text. That's all true, but it was the foundational technology that led to all of this. 2 years later, we now have agentic systems. Now, that's one view of AI. I just described the view, which is what can AI do, right? And so now all of you realize you see it from ChatGPT, you see it from Codex, you see it from Claude Code, you see that it's now able to not just understand, but it's able to do work, reason and do work. Now, 2 years ago, when AI was able to understand you and generate information that was interesting, novel, a little cute, whenever you need a poem written, great way to do it, right? Who doesn't want to write a country song? And so that was 2 years ago, but now, because it's able to do work, AI is valuable. Valuable meaning it can generate information, it can generate useful work,
and it could be paid for. Because we're interested in having friends that are smart. We love people who are know-it-alls, but we don't pay them for it. We pay for people who do work. Does that make sense? All right, which is what happened in the last 2 years. AI went from having this capability to now agentic, went from not very valuable to now producing useful work. So much useful work that you and I are doing this every day. We're paying AI by the hour, right? And so we might pay them $30 an hour to do the work, $20 an hour to do the work. We're basically paying AI a lot of money today, the fastest growing software business in the history of mankind, because now it's doing useful work and we can pay them to do it. Now, that's one view of AI, which is what it can do. But one other view of AI that's really important to help reason through what Konstantin's saying. So, for example, the reason why some people are able to build great businesses and could maneuver themselves into the center of very large industries is because when they see this capability, this is very interesting. One interesting thought is, if we're able to do this, what is the implication to this downstream industries? That's an interesting conversation we should have. Okay? So now that AI can do this, what happens to all the industries like healthcare and financial services and life sciences, manufacturing, logistics, transportation, on and on and on. E-tail, advertising, future entertainment, the list of conversations you have about now that AI can do this, what can it do as a result subsequently? That's an interesting conversation. But you should go upstream, meaning industrially, what does that mean? And so the first thing you realize is this. Go back to first principles. I had told you just now that AI is software and it's being produced by a computer. Now, what happened to the computer that has made it possible to do this? Well, the big idea is if you think about the computer as we know it today, really emerged about 64 years ago. IBM System 360 was the biggest announcement of computing, and 64 years ago, IBM was the most valuable company in the world. Okay? And they created the modern understanding of computers. Everything that we can describe about a computer was really described in 1964. For 40 years, largely has remained the same. And what happened was that that form of computing is called pre-recording. You write down your story, you save it to a file. You write a program by hand, you save it to a file. You take a picture, you save it to a file. You record music, you save it to a file. You make a video right now, we're in streaming right now, but somebody's going to record it, you're going to save it to a file. And when you want to use it later, you retrieve it from the disk drive. Does that make sense? And the retrieval process is done intelligently. So that's why everybody's retrieval of a news story is a little bit different. It's called a recommender system. But basically, computers as we know it today is a retrieval-based system, which is the reason why these buildings are called data centers. They store data. Notice they don't call them computer centers. Because they're not doing much computing. They just store data that you retrieve based on what you touch on your phone. Well, what happened now, if you look at what I just described, in order for this AI to work as I described it, every time I say something to it, I have to give it new information. We call it context. I give it a new prompt. That's called a query. Between the context and the query, it will understand it first, reason about it, and it will produce an output based on that context and that query, based on the circumstance. Does that make sense so far? Okay, give me one nod. Okay? And so, if that is the case, every time you use the AI, the content is produced originally every single time. Everything I'm saying to you right now is being produced in real time. And it's because my explanation is based on the fact that I realize all of you come from 60 different countries, 128 different families. You all have many different backgrounds. Some of you probably came from the computer industry. Most of you probably did not. And so I'm explaining the information to you in a way that is sufficiently deep, but ultimately my goal is this, so that you know how to make your next investment. That's what I'm leading to. And so I'm going to give you enough sufficient information that you can reason about it for yourself so that when you see something in the next time, you go, that's worth investing in. That's going to be a big industry. That's $100 billion right now, and it looks really big, but that's nothing compared to how big it's going to be. I'm going to give you the intuition to solve that problem, okay? And so here we are. Went from a computer industry that was largely based on retrieval for 60 years, and all of a sudden, one day, it's completely generated in real time. We call it intelligence. This is what I'm doing right now for you. I'm demonstrating intelligence. Contextual awareness, he gave me a prompt, and here comes my answer. Does it make sense? Extremely artificial intelligence. Okay? And so here what's going on now? I just gave you one word earlier. It's called generative AI. The computer of today has been completely reinvented. It's now generative. And every single letter you see, every single word you see in the future, every video, every image, every ad, every TV commercial, every single time you read a story, a news story, every one of them will be different. What Constantine sees, what I see, what you see will be completely different because it'll be generated for you. Because your interest, your context, who you are, for what reason you asked, how you asked is completely different. Does it make sense? And so therefore, every single pixel that you see, every single sound that you hear in the future, every video you see in the future will be originally generated, not retrieved. Which means in the future, we need a lot more generators. And these generators is what we build. That's what we build for a living. These are large computers, and they're generating intelligence. Now the next question is this. Well, how big could it be? How big can it be? And so it turns out, the amount of information, the amount of generation of intelligence is, we do it for about 1 billion people in the world today. Now that I've told you that AI has become agentic, meaning that it can actually do work by itself. Well, if it can do work by itself, then one agent can communicate with another agent and say, I have some work to do. Let's team up together and let's do some work. And now you have all these different agents, and they're all working together to solve problems inside your company, say. So inside our company, Constantine knows that we're huge users of agentic AI. We have hundreds of thousands of agents probably running around right now that are doing work, and they're talking to each other, and they're solving problems. They're all guardrailed, all sandboxed, but they're all working with each other, which means in the future, it is very likely that the internet that we use today for 1 billion people will likely mostly be several billion, call it 100 billion agents working around the clock, and they're using the internet and talking to each other. And what are they saying? So for example, there'll be companies working with companies, employees, agents working with other employees, agents. There'll be self-driving cars, which are agentic. There will be robots, which are agentic. All the manufacturing systems, every building will be agentic. There'll be agents all over the place, and they'll be using the internet. And all of those commands that they generate to each other will be generated. All of the thoughts that they have to understand, all generated. Does that make sense? And so basically the world is going to be this layer of computing that's going to cocoon the earth, and it's going to be generating intelligence all the time. Now, I just said something that sounds ridiculous, except, in fact, it's already happened twice. So 300 years ago, a company in Germany called Siemens produced a machine. And this machine is a really interesting machine. You go up to this machine, you light it on fire. And then this incredible invisible force comes out the other end. Nobody understood what it was. We understand it now as electricity. How many power generators are there in the world? We call it a grid. Power generation cocoons the planet. We call it the grid. And then, of course, 20 some odd years ago, earlier than that, 35 years ago, this networking scheme, networking matrix fabric was created here in the United States, eventually became the internet. And where is it? It cocoons the world. And so now you have energy, communications, intelligence, and it will cocoon the world. And we'll use it for, it'll just be a commodity, and we'll use it all over the place. And so what NVIDIA does for a living is this new machine. The machine that was invented 300 years ago is called the dynamo. That dynamo, anything that moves comes in. It could be, waterfalls. It could be wind, fire, steam. Transfer it from motion, atoms, right, to electrons. Atoms to electrons. We then take the electrons into our machine called NVIDIA. Electrons now comes into our machine, comes in this factory, and what comes out are numbers. These numbers, depending on how you combine them, turns into language, math. It can also turn into a new language we've learned, proteins. We learn the language of human biology. We learn the language of the physical world, physics, climate, weather. We learn the language of the 3D world, robotics, self-driving cars. We learn the language of all kinds of different forms of intelligence. But the point being, now, these two machines, 300 years apart, atoms in, electrons out, electrons in, numbers out, and those numbers could be rejiggered, reformulated into all kinds of different intelligence. That's what we build. That's what we do for a living. And that's why I call it a factory, because it's producing, we call them tokens, but they're just numbers, tokens, and these tokens are intelligence. That's it. That's what we do. It's not that hard.
Brilliant.
Now you know what AI is for, and now you know how AI is built, and how big it's going to be.
Thank you all for joining today.
Thank you. Good job. Excellent question.
I really felt that carried it. The prompt.
You laid it up for
Yeah.
me.
Okay, so this is a massive revolution.
Yeah.
And you laid out 3 transformations. Energy transformation, which touches everyone today, and a lot of the people in the audience are part of these manufacturing and energy producers globally. Telecommunications, which connects all of us, and now intelligence. And in energy, you talked about the generator. Telecommunications, I guess the comparable would be the switch or something along those lines for routing communications globally. And now in the intelligence revolution, it's the GPU at the core. And the AI factory like the H100 or any of the new systems that bring everything you need under the same hood, Vera Rubin, what have you.
And these factories, so you know, these generators, it's each one of our units, we call it a rack. There's 72 chips inside. We manufacture, call it 8 million of them this year, but 72 of them go into a rack. That rack weighs 2 tons. It is $4 million, has 1.5 million parts, and it's the most expensive piece of equipment in the world. And we manufacture them like I guess it would be like phones. I mean, we crank them out, and they go to data centers all over the world. And yeah, we build these machines in volume.
They are big devices.
Yes.
This is how you do your weightlifting.
Yes.
I understand.
No volume discounts.
Okay, so you laid out this picture of a very exciting world that we are in. We're in the middle of this revolution. We're, you could say decades in, you could say years in, certainly now in the mainstream of the intelligence revolution. How do we participate? I'm sure everybody here wants to participate in this revolution.
Yeah, excellent question.
Let's start with big enterprises, and then let's get to individuals as well.
Yep.
How do people join this movement?
And so now I gave you 2 mental models. I'm going to give you one more mental model. So one mental model, they're really, we could talk about this story and hopefully we cover all 4 phases. I just talked about what AI can do. I talked about how AI is made. And these things are in these factories. These factories are, each gigawatt is about $50 billion. So if you ever seen, it's the most expensive factory in the world, but it also, that one $50 billion factory also generates 300, $400 billion in intelligence. And so the production value is incredible. Okay. The return on investment is extremely fast. And so that's the factory part. The part that I'm going to tell you now, and this is very important when you think about investment, is what does the industrial layout look like for AI? And the way to think about the industrial view is think of it as a 5-layer cake. Now, I told you on the bottom is energy. The bottom is, remember I said the dynamo, okay? Now we have, of course, different AC generators and things like that, power generation. And so on the lowest layer is energy. This is the single greatest opportunity in several generations for the energy industries to grow. The very first time in probably, I don't know, 100 years since the energy grid in many countries could be invested in, this is the best opportunity to invest in sustainable energy. If you care about sustainable energy, nuclear, air, or wind, solar, you name it, whatever form, hydrogen, whatever form, so long as it produces energy, it's going to get funded. And so that tells you something about how great of a time this is, because we have $1 trillion. Just think, this year alone, we're going to put $1 trillion from the market into this entire 5-layer cake I'm about to describe to you. So the first layer is energy. That's the reason why
He loves saying that 5-layer cake shit.
is doing fantastically. GE, Vernova, I mean, everybody. The first layer of the
Loves that
cake
shit.
is energy. The second layer of the cake is chips and computers and networking and switches and silicon photonics. Does that make sense? It's all the computers. The third layer of the cake, we call it infrastructure. Land, power, shell, money, data center operations. Every one of them in scarce supply today.
Oh
And so
my God.
that's the next layer, is infrastructure layer. And then the layer that everybody sees, that everybody thinks is AI, is the model layer. Does it make sense? That's the next layer. It sits on top of the computers, the cloud infrastructure, and this is the greatest opportunity in recent human history that I know, that so much market-driven investment is naturally coming into the ecosystem. This is a great time to build. And so now that's the model layer. The
Motherfucker.
model layer is OpenAI, it's Anthropic, but this is the part that you can't overlook. This is very important. So you have two companies that you know of, that you hear about. However, don't forget, AI, as I was explaining earlier, has learned the language. It learns the language and the meaning, the language, the meaning of anything that is structural.
It's like you're not reading what.
What's really important is, so we talk about all the language, but don't forget, you can learn anything with structure. And so let me give you an example of something with structure. Today, when I walked into the room, I was expecting a lot of people, and it wasn't unexpected the way you appeared. Now, if some of you were hanging off the ceiling and floating in midair, and some of you, the one human, but body parts in 17 different places, and I could see through some of you, then it's hard to learn that, because every time it's different, okay? Because it's hard to learn quantum things. However, things with structure we can learn, right? People have eyes, and so you can learn these things, okay? And so 3D, I learned the laws of physics. I sat down, and notice I sat down with confidence. I wasn't 50%, 53% of the time I landed safely on the chair. The other 47% of the time I went right through it. And so I can't trust it, but 100% of the time. Do you guys understand? And so if things are predictable and are predictable, then there's structure you can learn from it, and you can learn the meaning of it. Okay? And so we learned the meaning of proteins. We're learning the meaning of genes, not just sequencing it, not just CRISPR editing it, but what is the meaning of that gene? What is the meaning of a cell? Why does a cell do what a cell does? What happens to two cells coming together? And so this is no different than, imagine I learned the meaning of a cell the way I learned the meaning of a word. And what happens when I take two words, put them together? These two words activate each other, turn into something else of another meaning. Okay? And so from a computer's perspective, it doesn't care if it's a cell, a protein, a word, an image, a car. Does that make sense? It's just tokens. And so we have to figure out, as computer scientists, we have to figure out how to represent the world's information in all these different ways so that the computer can understand it. understand it, reason about it, come up with a plan, generate an action, the intelligence loop. Proteins the same way, cells the same way, human anatomy is the same way. It must be predictable. It's predictable because tomorrow morning I'm largely the same. It must be predictable, okay? And so we're learning all these different. My point is, there are two language models that you guys know about, but AI is a giant industry. The industry of everything else physical is about $80 trillion. It is actually, the most important frontier, the parts that we're not talking about. And then on top of that, this model, this technology, then feeds into all the stuff that Constantine gets to see these days, which is all of these startups that are coming up with revolutionary ideas in financial services, in legal, in accounting, in transportation, logistics. Isn't that right? And so what that layer above, this last year, $100 billion of venture capital investment, the single largest year of VC investment in the history of humanity. All of that money is going into that fifth layer, the top layer, which is the layer that apply applications to enhance human condition. And so there are 5 layers. When you think about AI and you want to invest in this future, and I promise you this future is going to be gigantic because 2 years ago, 0. It's approximately, we're about to put $1 trillion in, but that's $1 trillion out of the, we're going to be putting in probably the AI industry, I'm going to guess for a second, probably something along the lines of $20 trillion a year. We're $1 trillion in of a $20 trillion a year ecosystem. Because the production of intelligence, you just got to ask yourself, how important is intelligence? And who needs it? And how much of it do you want? And so those are kind of the basic questions. And all of that intelligence, whether it's for proteins or cars or robots or language or math, science, whatever it is, has to be generated by these machines. So this 5-layer cake is the industrial version. And I think that's a good way to think about where to invest.
Hugely so. So you've described what is a multi-trillion-dollar opportunity to become part of this revolution. And that includes the hardware and the facilities. If it's $50 billion for a gigawatt and there's 100 plus coming online in the next several years, that is trillions, plus the application layer where that is many, many more trillions, plus, plus, plus. And that means real jobs for people doing the hands in building, and then also
right now, exactly. And
Yeah.
we have to really emphasize this, and this is very important to you. Every country has a different attitude about AI today. Would you guys agree with that? Every country, because everybody's culture is a little different. Okay, and here's my recommendation. Be careful with the analogies and the science fiction stories that this is Terminator and words like singularity and ideas that somebody say in 20% chance this will be the end of humanity as we know it. Okay, those kind of articulations of AI is just nonsense. It is complete nonsense. Oh, we have no idea how it works. This is so mysterious, we don't even know how it works. It might just get up out of its seat and walk out tomorrow morning. There's no question in my mind it's computer and software. And there's no question in my mind they know how it works. And do you know how they know how it works? Because every single year, apparently, it's getting better. If you don't know how something works, how do you make it better? I have no idea how it works, but I know how to make it better. That's nonsense. So why are they saying these things? That's an interesting question. However, don't let it scare you. You must engage it. You may or may not lose a job to an AI. You will absolutely lose a job to someone who uses AI. You agree with that? Okay. So let's not worry about the things you're not sure about and focus on the things that you are sure about. I am absolutely certain I will lose my job to someone who uses AI. So before I worry about AI, let's just go make sure I use AI. And so the part that, now why is that common sense so important for me to tell you? Because some of you have children. What are you advising them? Run away? Or make sure whatever this technology is that gives people superpowers, that you go make sure you use it. So I'm hoping that we do two things. One, we are and we're doing everything we can to build this technology safely for the world. I promise you, so much computer science, so much investment, so much passion dedicated to making this technology safe for everybody to use. And I can prove it. Use ChatGPT 2 years ago and use it again. The amount of hallucination completely reduced to almost nothing, to the point where it's producing knowledge not only accurately, contextually relevant to the moment, and if it doesn't know the answer, it does research, and when it comes up with an answer, it even questions itself. Before it tells you an answer, it reflects on it, and it comes up with two or three different answers, and it reflects on those before it produces the answer for you. The amount of safety and guardrailing, grounding of truth, the technology had advanced so fast to make it safe. I am certain I can tell you this completely with fact. I prefer my car today than the car that was 100 years ago. The technology is a lot better, but it's a lot safer. And it takes a lot of technology to be invented in order for it to be safe. And so I can tell you that it is our job, it is the responsibility of the technology industry, the responsibility of scientists and engineers for us to build AI safely. Two, it is your responsibility to make sure that you tell the people that you love, whether it's your family, your kids, your grandkids, or the company you work for, or the country that you're in, whatever we do, engage AI. If we think it's a superpower, engage it. Because if we don't engage it, somebody else will. We're not going to lose our lives to AI. We're going to lose our lives to somebody who uses AI. And so that's that's too serious.
That's
too serious. Because he said the word job. So I've got a trigger, and the trigger is a bunch of people making stuff up about jobs. We put $1 trillion into the world's ecosystem this year, did we not? What's it doing? Making jobs. Right now, the energy sector, more jobs than ever. The chip sector, more jobs than ever. Infrastructure layer, more jobs than ever. Everything from land, power, shell, finances. AI model layer, more jobs than ever. And we just said $100 billion last year went into the upper layer, more jobs than ever. We're creating so many more jobs. Now, somebody might say, well, what about the traditional jobs? So let me give you the example. You know that everybody's job and their task is related, not the same. A job and the task you do in the job is related, not the same. So, for example, my job is to be the CEO, to lead the company. Most of the time, and I spend a lot of it today, most of my time, my task is typing and talking. And so you could say CEO equals typing and talking. Both of them, AI does in a superhuman way. And I'm busier than ever. And I'll give you that. Of course, that's a really cute example. But let me give you a deep example, and you can now apply it. So 10 years ago, slightly more than that, one of the world's leading computer scientists wanted to warn everybody about the power of AI. And so he said, and Constantine probably knows who it is, he said, the first job that AI will destroy and eliminate, and I advise nobody goes into this field because this field will be wiped out, is radiology. Computer vision is superhuman already 12 years ago. Computer vision. A computer can recognize images, detect anomalies with superhuman capability, never gets tired, never miss a detail. 12 years ago, it was able to do that, and he predicted as a result of that, radiology is going to be wiped out. Well, he was absolutely right. Radiology was completely penetrated by computer vision. Computer vision proliferated through every single form of radiology, and every radiology stack and every radiologist today is augmented by computer vision. However, the interesting thing is this: radiology demand went up. The number of radiologists in the world went up. Why? Audience participation, please. Why? I heard some of the things, it's all true. It turns out radiology spends a lot of time studying scans. But the purpose of the radiologist is to work with doctors to diagnose disease.
Mm-hmm.
To work with doctors to diagnose disease. And because it's now automated, they are more productive. So two things happen. More patients are admitted into the hospital. They do more scans. The radiology department became more profitable. When they realized they were more profitable and they were admitting more patients, they hired more radiologists so that they could admit more patients, so that they could make more money, take care of more people, because as it turns out, there are a lot of people who are suffering and they're waiting to get into the hospital. So now, let's pretend for a second. Do you appreciate the computer scientists tell you it's going to be the end of the world for radiologists? My point is, we have to be responsible about what we make up, because we could have done harm. And it turns out the number of people who want to be radiologists after his speech, because it permeated through everything, the number of radiologists started to decline. But we need more radiologists. Now, somebody recently said 90% of software coding will be gone, and therefore we don't need software engineers. Meanwhile, we're hiring more software engineers than ever.
Yep.
And the reason for that is because a software engineer's job is to solve problems and dream up problems to solve, innovate. I never hired somebody and said, hey, guess what? You're a software engineer. Listen, here's a keyboard. Show me how many words a second you can type. Typing is not the job of a software engineer. Coding is not their job. Solving problems is their job. And so I just gave you two examples: task versus purpose. Does that make sense? Mm-hmm. It turns out this example happens all over the place. But because we have such a contrived, such a naive understanding that computer scientists could say things like 50% of the jobs will be gone, software coding is completely irrelevant, radiology is going to be wiped out, because we think about it from the task perspective, we forgot the purpose of the job. There were radiologists before there were workstations. There are going to be radiologists after AI. There were engineers before software coding. I promise you that. There will be engineers after. Does that make sense? And so that's the way to think about jobs. And I've now covered two things. One, if your country is not investing in AI, there's a massive boom of jobs that you're missing out on. If your country or your company is not investing in AI, there's a level of elevation of your people that you're missing out on. AI is not going to eliminate jobs. AI is going to elevate your job. If I were a plumber today, largely I get a job task sheet or a schematic. However, if I'm a plumber tomorrow, it is very likely I'm a designer as well. Does that make sense?
Yes,
because you and I both know that we could just use AI to generate these incredible designs of a kitchen. If I'm a carpenter, I can turn. If I were a salesperson of furniture, to be an interior designer for sure. And so I've elevated my craft. Went from somebody who sells furniture to somebody who could advise you on how beautiful your home could be. I went from somebody who's a carpenter. You expected me to come and just, put some wood together. And now I'm your home designer. I've elevated my craft. I've given you so many examples, but that's my point. I think the narrative about AI is absolutely wrong.
Mm-hmm.
And the goal is to scare everybody out of it. so that some people could benefit from it. But AI, as you know, is the greatest force for eliminating the technology divide in my entire career. I spent 40 some odd years, my entire life has been in computer design. I spent 40 some odd years, and this entire time, the technology we created became more and more and more and more complex. And the number of people who could program these computers as a percentage of population declined. Yep. Who in this room knows C++? Come on, cut it out, you weirdos. This row is just okay. And so so this row, okay, so we're looking at 2%. Okay? 2%. And this is a very strange room. This is a very strange room. And so 2% of society knows C++. How many people know human? Okay, more than 2%. And so everybody now can program a computer, and yet in the past only 2% can. We have closed the technology divide. We got to bring everybody with us. Does that make sense? Okay. Anyways, that's it. On a Friday night, that's too serious.
That is extremely optimistic, and I agree. And it's great to hear from someone who is closer to actual building of the actual technology that powers everything than anyone else in the world. So Jensen, you talked about a future where we move from retrieval, this paradigm that we've had our entire lives in, to generation, where everything is customized, knowledge is customized for the individual, a world where we have the generation of intelligence paralleling from the energy to the telecommunications revolution to now the intelligence revolution. You talked about these languages that the computer can speak, not just English or German, but even protein. You talked about 5 layers of participation, an abundant opportunity to participate in this revolution for everyone in this room and everyone listening. And you talked about how this transformation is going to be something that has real consequences that allow people to move from just doing the task to dreaming the problems and the solutions, maybe even a life of purpose and a life where we move from carpenters to architects. Thank you, Jensen. Please join me in thanking Jensen Huang, the man who made this all happen. Thank you. Thank you so much.
You're awesome. Really appreciate it. Thank you.
That was
I love this library.
It is an absolutely beautiful library.
Are you a big reader?
I mean, I read a lot in general. I don't know that I've had that much time over the last year or so.
Dario Amodei is an unlikely AI celebrity.
Dario Amodei.
Warning the world about the risks of artificial intelligence. Now, his company is AI frontrunner, valued at nearly $1 trillion.
You're shipping so much so fast. How are you doing that?
We use Claude, across the product development cycle, and it allows us to release very fast.
Founded by a team of OpenAI defectors in 2021, Anthropic started out as an underdog lab. Today, it's the breakout star, wiping billions in value off software stocks, going head-to-head with the Pentagon, and creating models allegedly powerful enough to burst through the walls of modern cybersecurity.
Some of the early companies that we gave this to said things like, "This is a super weapon. Please don't release this."
Guiding Anthropic through this is a sibling duo. Dario, the brother and visionary, and Daniela, the sister and operator, who puts Dario's swirling cosmic thoughts into action.
Dario and I, we've always been really close since we were little, but I think we always really wanted to do something big together.
Okay, but when you argue, who wins?
No one.
No one.
As the AI arms race escalates, the Amadeus are eager to establish themselves as the good guys. But Anthropic's technology could have profound implications for how humanity works, learns, thinks, even fights wars.
Anthropic is run by an ideological lunatic.
This is a debate about what the proper use of AI by the government is.
At some point, the model is very dangerous. You know, the bad guys will have it too. And at that point, we have to make sure the good guys have an even better model.
The name Anthropic actually comes from the Greek word for human, which speaks to their mission to build responsible AI for the long-term benefit of humanity. Can you actually do that? You're building the most powerful technology in the world. You are at the center of the AI universe right now. What does that feel like?
The experience I've had for my whole career, and certainly the whole time at Anthropic, is that there's this kind of smooth exponential. And the experience of the smooth exponential is nothing's happening, nothing's happening, nothing's happening. Little things happen, and then zoom, it goes crazy. So, I was watching this graph for a while, and I said, oh, yeah, we'll probably become the AI company with, the most revenue and the most valuation sometime around this time. And indeed it has happened. We're just keeping in mind all the things we usually keep in mind. How do we train good models? How do we put them in good products? How do we make sure that everything's safe?
What were you like as a kid growing up in San Francisco? I know your dad was a leather craftsman, your mom worked in libraries. How did that shape you?
The whole, first, internet revolution was happening around me, and I had absolutely no interest in it. I was just interested in doing math and scrolling things. I was interested in understanding the universe. I was interested in science fiction. I think I just felt a lot of curiosity about the world.
What was it like growing up with Dario?
He was so smart. He was taking, calculus when he was, in, I think, middle school. He took math classes at UC Berkeley when he was in high school. I was actually more into reading and arts, so we were almost like complete complements in that way.
Dario studied neuroscience before turning to AI at Baidu and later Google, while Daniela started out as an early employee at Stripe. They lived together in San Francisco, along with Daniela's husband, Holden Karnofsky. Then, in 2016, Dario joined the newly formed OpenAI, followed by Daniela in 2018. The company began as a nonprofit that promised a safe, more open path to superintelligence.
I think we need to think right now about how we want this deployed, how everyone gets to benefit from it, how we're going to govern it, how we're going to make it safe and sort of good for humanity.
At OpenAI, Dario developed the concept of scaling laws, predicting that large language models would improve simply by adding more data and computing power, even if the underlying algorithms stayed the same.
At that point in time, I know it sounds crazy now looking back, not a lot of people believed, hey, scale up is the way that these models are going to get smarter and better. That was sort of an unusual, countercultural, scientific perspective that I think was really held by our, founding research team.
That approach helped supercharge OpenAI's models, paving the way for ChatGPT. But the Amadeus reportedly clashed with Altman over the company's direction and values. Altman has said, "For all the differences I have with Anthropic, I mostly trust them as a company."
Your decision to leave OpenAI has become Valley lore. What did you disagree on?
Look, I'm going to say it. I'm going to say it very simply. There are many valid disagreements to be had on safety. We certainly had some of those disagreements with them, but people that alone is not sufficient to leave. When you feel that you can't trust someone, when you feel that their values are not what they say they are, when you feel that they're not honest, that makes it very hard to continue to work with a company, to continue to trust the company. And look, at the end of the day, why argue with someone when you don't have the same vision and you don't trust them? The way to resolve it is you go off and do your thing. They go off and do their thing.
So this is Precita Park when Dario and Daniela decided to leave OpenAI to start Anthropic. This is where the early team would get together. It was during the pandemic, so the story goes, and a bunch of early employees would come here, they'd pull up a chair on the grass, they'd have lunch, and they'd talk about what they were building.
When we started this company, there were 7 co-founders, of which me and Danielle are 2. And now, you know, we're basically the only company in the space that has all of its co-founders still here. You don't get to, you know, be a company of the size and scale that we are with that happening. Like, that almost never happens.
From the start, Anthropic pitched itself as the ultimate safety-conscious AI company. Dario has published long essays with names like Machines of Loving Grace and The Adolescence of Technology, musing on the miraculous potential of AI, as well as the worst-case scenarios. Anthropic's chatbot, Claude, has been trained to follow a set of principles called a constitution, intended to keep it on the straight and narrow.
Claude has a very distinct style and feel, a human name. What are you trying to convey?
I think when people interact with Claude versus, you know, other systems, there is more of a feeling of, I like to describe it as professional warmth. So the goal is not for it to be your best friend, but it's not for it to be sort of cold, rote, calculating. It should feel approachable, but distant, right? Professional.
Anthropic has talked about teaching Claude to be good. What is a good model? What is a bad model?
You don't want a model that lies accidentally or intentionally, right? Lying we call hallucinations. It makes something up. The models are just trained to predict the next word, so sometimes they don't know, and they just invent something. Models sometimes, as we've shown in our research, can purposely try to deceive you. We have to make sure that doesn't happen in production models that we expose to customers. And then there's a lot of work around harmlessness, just making sure that the model is not accidentally producing, you know, information that is wrong or harmful or could cause someone to do something bad.
Whose values are being put into Claude? Like, is there a universal good? There's so many religions, so many different beliefs. Like, how do you even decide that?
So, of course, there's no universal standard for what makes something helpful or harmless, but there are founding documents in human history, like the UN Declaration of Human Rights, that we can use to train Claude's character. And I think, you know, interestingly, on the religious front, we've actually started to have a lot of conversations with religious leaders around how should we think about, you know, Claude's entity, and how can we bake in some of the kind of core values that are consistent across religions, types of belief, that really just transcend, you know, a specific worldview, but that are really things that human beings have been grappling with for millennia.
Have you tried to give Claude a trait that didn't take, or was there any trait that emerged that surprised you?
I think in the early days, it's funny to look back on them now, the kind of early Claude 2 era. Sometimes Claude would be almost a little bit nanny-ish. Claude was like, I'm really concerned about you. And you're like, Claude, I was asking for the weather, right? It was something really benign. Thankfully, we didn't, you know, release most of the most egregious versions of those. But I think it is, you know, it is, when you think about it, it's like tuning a dial. And so our researchers have this very fine needle to thread in order to land at the center of that.
Whatever Anthropic is doing with Claude, it seems to be working. Anthropic's revenue has skyrocketed over the past year, making the company profitable for the first time. That's largely thanks to the company's focus on more lucrative business tools. Claude Code, a major leap that automated large chunks of software engineering, and Claude Cowork, which gave that power to everyone else.
Now, early on, others focused on fun, splashy consumer apps. You made a bet on coding and enterprise. Why did you make that bet? Was it a values decision or a business decision?
Look, if you pick a business model that fundamentally conflicts with your values, you're going to have a hard time, right? Either you betray your own values or you become irrelevant. And so when we thought about it, we said, look, you know, we've seen the world of social media, the consumer world, it really seems to, you know, encourage engagement, even addiction, you know, the flop we've seen with AI video models. It's like, what's going on is it want to maximize the number of minutes that you're paying attention to because that's the advertising revenue driven incentive. Whereas if we look at enterprise, look, I mean, you know, we want to make these models useful to people. We want to use AI to you know, cure diseases that we couldn't cure before, right? Well, that's working with biotech, it's working with pharma, it's working with academic research groups. All of those are enterprises, right? We want to use AI to, like, you know, to make energy cheaper and more efficient. That's all enterprise. And so I think it served us well to have this business model that largely aligns with our values.
Soon after Claude Cowork was released, $285 billion in market value vanished overnight. Traders called it the SaaSpocalypse.
This kind of white-collar wipeout story in the software sector, terrifying.
Some of those are down for 9 days in a row, so clearly the tension is building.
If AI continues improving at this pace, how much of traditional software gets replaced and how fast?
I think with AI, like, the pie is getting bigger, right? So the existing incumbents may be smaller in relative terms. Some of them may go down in value. Some of them may even go out of business if they don't adapt in the right way. But, like, I would guess that the software industry gets larger, not smaller, although there will be some big losers. Those who don't kind of see what's coming, who don't identify the moats they have, they're going to have a really hard time.
Okay. Anthropic's recent growth spurt might not have happened without this man, Boris Cherny, the engineer behind Claude Code and Claude Cowork. When Anthropic hired him in 2024, Cherny was living a very different life in rural Japan.
There was a lot of farmers markets, like very slow. We were making miso. That was sort of the big hobby. And I remember using the first AI chatbot that I'd ever used. And it just took my breath away. And I was just like, oh my God, I have to just be a part of this. And I'm also just such a big sci-fi reader. And so I just know how bad this thing can go. Like, this technology is incredibly powerful. And so we moved back.
You created Claude Code. You led the development of Claude Cowork. What problem were you trying to solve?
If you look at the coding products, they were all pretty simple. It was sort of like, you know, like complete the word, complete the sentence. That was the extent of AI in coding. And we just wanted to make a way bigger bet. And our bet was, we think actually a coding agent can do all of it. A year and a half ago, you wrote the code by hand. And sometimes you press tab and it would autocomplete a line. Now I talk to my Claude and it writes the code. And then while it does that, I talk to the next Claude and it writes some code. And at any point, I have either, you know, like a few Claudes running and up to a few thousand Claudes running, doing things.
How much code is Claude writing internally for engineers here?
It's writing almost all of it. On my team, so for me personally, it's been writing 100% of my code that we see months. The work of engineering has just completely changed. I feel like I suddenly have superpowers. I have like a jetpack. And engineering has never been this fun.
Can we give Claude a spin?
Yeah, let's do this.
All right.
All right, so let's make like a little recipe app. So make a recipe app. What do you want it to do?
I would love it to suggest meals for the week.
So, you know, this is going to take maybe a few minutes. And let's just see if Claude builds this.
Oh, it gave me some options. Let's do...
These look pretty tasty, actually.
I could do a Greek chicken power bowl. When I click on a recipe, I want it to show me how to do it. Thank you.
I'm sure Claude appreciates it.
I always try to say thank you.
Yeah, I always try to be nice too.
I don't know.
A recipe app might not be the most mind-blowing demo of Anthropic's technology, but what Claude Code just did in minutes used to take hours or days. For some, that looks like a big opportunity.
Are you like nervous about next week, or is it like...
What's next week?
Your developer conference.
Oh, yes, yes. There's so many things happening every week.
Year over year, API volume is up nearly 17x on the cloud.
In the last 12 months, we shipped 8 frontier models to developers and users.
Welcome to the second annual Code with Claude conference, where Claude superfans come hoping to get a glimpse of the future.
We're having a lot of There's a ton of adrenaline.
This is the first year we've grown faster than the exponential. In the first quarter of this year, we saw, if you were to annualize it, 80x growth per year.
Ooh.
I use Claude every day in the form of Claude Code to do all sorts of stuff, not just write code.
I write way more code than I did 5 years ago. I've got the confidence of, I don't know, a 22-year-old with VC money. I'm not 22.
My friend invited me, and it's amazing as someone that's not really technical. I think it's really interesting just to see what everyone's working on, what's out there.
I think the concerning part and the exciting part is, hey, they can do things that we couldn't dream of, and timelines we couldn't ever expect. But the kind of alternate side of that reality is you really have to be prepared because they will really be 1,000 times more productive.
All of this is an obvious question. Will engineers be the first casualties of the AI they're building?
It's been revenge of the nerds for a while. Is that over?
I think we all become nerds.
But what happens to the actual nerds?
I think the actual nerds, well, they have to figure it out. Yeah, I think for a lot of them, the skill that they had before is going to help them in the future because they sort of have a pretty big head start. They do a lot of things that are not coding. Engineers also have to talk to users. They have to plan. They have to think about what's next. So I think these are still parts of engineering that are going to stick around.
Silicon Valley may have AI fever, but elsewhere, the mood is less upbeat. 70% of Americans think AI will kill jobs, and nearly a third worry theirs will be one of them. Dario Amodei has been outspoken about this issue, and some of his predictions don't exactly sound reassuring.
I think we could have this very unusual combination of very fast GDP growth and high unemployment, or at least underemployment, or low-wage job, a lot of low-wage jobs, high inequality.
You've been really direct about job loss. AI could eliminate half of all entry-level white-collar jobs in the next 1 to 5 years. That was a year ago. AI has moved incredibly fast. Is it still 50% or is it higher?
I don't know exactly, but I'm still pretty concerned. I'm still the same order of concern. We are seeing right now that AI is making people more productive, but that's the usual hump. You automate 90% of the job, great, people are 10 times more productive in the other 10% because they're 10 times more leveraged. But eventually it gets close to 100%. Now, the sequel to that is, well, then you have to find something else for them to do. Right now, AI makes the software engineers more productive, even though AI writes all the code or almost all the code. But we're already starting to see the beginning of there may be some people that it's not making more productive, that it's better for the AI to just do the thing.
How does that sit with you?
It's very uncomfortable. Yeah. I think this is the reason why I chose to go to Anthropic. And I think this is the reason that a lot of people here chose to go here, is artificial intelligence is this force that is far bigger than we are. But here we can hopefully make it go a little bit better.
Do you feel like it's your job to do something about that, or is that someone else's problem?
I think it's a thing that we have to talk about. We have to advocate for it. Ultimately, it's up to society to solve it. This is bigger than one company.
There has been a lot of pushback on, and I know you've said you're trying to warn people, but that, Jensen Huang said you're conflating tasks with jobs.
AI is creating jobs. Anybody who is saying that AI is wiping out jobs is scaring people.
Other folks have said this, it's sort of doom marketing that benefits Anthropic.
So I want to be really clear and push back hard against this. In every interview, I talk about the possible ways to address these risks, from tax and macroeconomic policy to what the new jobs are. In the adolescence of technology, I have like 5 pages where I lay out the difference between tasks and jobs, why this time is different than other times. But social media, which I detest as a category, people have these 3-second clips from a year ago. I've written much more carefully about these things where I talk about the risks. So these are the idea that this is cheap marketing is itself cheap marketing. I think it's part of the disease of Silicon Valley. It's been caught up in this social media world of 3 seconds. And so my message is just definitely not doom is coming. My message is like, this is something, that we should see coming, that we're worried about, and that we need to actually respond to positively.
Beyond the software industry, the potential impact of AI on jobs seems harder to predict. Anthropic has published a paper estimating which fields could make the most use of AI in the near future. If its predictions are right, management, finance, and legal jobs could soon look very different.
Which jobs go away? Who gets replaced? And what new jobs are created?
So no one knows for sure, because, the economy is unpredictable, right? The thing that we have going for us here is the pie is going to expand a lot. And so because the pie is going to expand a lot, there are probably going to be places where people can go. It's just a matter of finding them fast enough.
So play this out for me a little bit. You wake up in 5 years, what does this country look like? What are those people doing?
Yeah,
because if there's that much unemployment, is that not how revolutions start?
Yeah, no, this is the outcome we want to prevent. This is absolutely the outcome we want to prevent. I think there's a few places. None of them are guaranteed. We're not sure. But there's the physical world. We need a lot of more people to make, build, manufacture things in the physical world. Anything that's human-centered. I think that's going to be a big deal, right? People, or at least some people, want to talk to humans. So these kind of human relationship-driven jobs, I think those are going to be important. And I think there'll be some effort by the humans to kind of direct the AIs, right? At some level, it has to be in line with someone's values and someone's...
Is what will happen in medicine. Today, we hire doctors who are expert diagnosticians. I think AI is going to soon be pretty good at telling you what the suite of options of things that are wrong with you and what tests to run, and you won't need a doctor to do that. But an AI can't physically examine you and say, hey, does it hurt when I press, here? They can't have a bedside manner with you that says, tell me how you're feeling about this. How are you coping with going through this process? And I think we're going to pivot something like medicine to be much more focused on the interpersonal, because the diagnostic tools are going to become much better. But the interpersonal human part, that's not going to change.
Explain this to me. Daniela runs day-to-day operations. All the leadership team reports to you.
Yes.
No one reports to you. That sounds like a pretty sweet job.
It's incredibly freeing. It lets me do all the things that I do much more easily than I would otherwise.
Because she does all the work? Is that what you're saying?
If you had to go through the things I had to go through during DOW or no.
The Amadeus hope AI can have a utopian influence on society. But there's no denying the technology's destructive and dystopian potential. Anthropic is at the center of a technological arms race, with powerful governments vying for control. Dario has charged head-on into this arena. He's not afraid to blast his competitors.
And then I think there are some players who are YOLOing, who pull the risk dial too far, and I'm very concerned.
Who is YOLOing?
So that's a question I'm not going to answer.
Or critique the US government and Anthropic's own partners for selling AI chips to China.
It's a bit like, I don't know, like selling nuclear weapons to North Korea.
I've been very outspoken about the need for export controls on chips to China. I say this because I think it would be really bad for America, for the state of democracy in the world, for China to be ahead in AI capabilities. And it's like some of the chip makers obviously don't agree with that view, but it hasn't stopped me from saying it. Even after we've signed more partnerships, I'm sure they wish we didn't say these things, but these things are what I believe. And so, look, we're all adults here. We can work together on one thing while disagreeing about another thing.
Amadeus' statements about geopolitics date back to his days at Caltech. As a sophomore physics student, he developed a reputation as an anti-war advocate who believed scientists shouldn't sit in ivory towers. It's a worldview that would later define Anthropic's position on the future of war.
You've had a long-standing anti-war stance, and yet you were one of the first AI companies to sign a contract with the Department of Defense to operate on classified networks. These are the networks that the U.S. uses to fight wars. Explain that.
Look, I mean, the world changes. My view of this technology. You know, when I see Russia invading Ukraine, when I see the risk of China invading Taiwan, you know, it worries me that we have a kind of resurgent authoritarian bloc, that they're very aggressive and that we need to defend ourselves. You know, I may not agree with every policy of either administration, but, you know, that's why we've generally been supportive of this.
You've been working with Palantir since 2024.
That's right.
You know, their technology is used by ICE, police departments in Gaza. Is Claude being used for surveillance in other ways?
We don't work with ICE either through Palantir or anyone else. We don't work with CBP. I don't believe we work in Gaza. We're very careful about, you know, scoping our engagements to things that we believe in.
In 2025, Anthropic, along with OpenAI, xAI, and Google, won a $200 million contract with the Pentagon. Anthropic framed it as an opportunity to become the leading AI vendor for the government. Claude was reportedly used by the U.S. military in the operation to seize Venezuelan President Nicolas Maduro. Weeks later, everything started to unravel.
We bring you breaking news from Anthropic. The Department of Defense demand that Anthropic allow full use of its AI technology without guardrails.
Anthropic drew red lines, refusing to let Claude be used for mass surveillance and autonomous weapons, putting the company on a collision course with the Pentagon.
The tech giant facing a deadline today to accept conditions or be blacklisted.
Does a commercial entity have the right to determine how their products are used by the military?
Lawsuits were filed, and Anthropic was banned from the Pentagon, underscored by strong words from President Trump and Defense Secretary Pete Hegseth.
Anthropic is run by an ideological lunatic who shouldn't have
But that's not my question. My question is AI
decision making of what we do.
Do you mind being called an ideological lunatic or a bunch of left-wing nutjobs?
You know, I think worse things than that all the time.
What does winning this fight actually look like?
I won't even call it a fight. This is more a debate about what the proper use of AI by the government is. And AI is an emerging new technology. We don't understand the ways in which it's reliable or unreliable. We don't understand the ways in which it promotes our values or undermines our values. And so one of the things that I thought was important was to establish a precedent on some of the use cases we think are good, which frankly is most of them, and some of the use cases that we're concerned about.
A U.S. official has said, with the help of LLMs, the U.S. military has gone from being able to hit 1,000 targets a day to 5,000 targets a day. That means Claude can help kill more people more quickly. Are you comfortable with that?
Basically, you're asking, like, you know, do you believe in this country, right? Do you want this country to be a more powerful actor rather than a less powerful actor on the world stage? I do. I'm a patriot. It's not up to me. If we provide a technology, it's not up to us to say you can do this military operation and you can't do that military operation. Now, I might privately believe that this military operation makes sense and that military operation is a bad idea, but we're not going to deny the technology. You basically have to, you know, you have to leave policy in the hands of the military decision makers.
Bloomberg has reported that Claude is being used by the U.S. military in the war in Iran to do AI-assisted targeting via a platform made by Palantir, Maven Smart System. In February, a U.S. missile reportedly hit a girls' school in Iran, killing more than 150 people, most of them children. Did Claude play a role in that strike?
We don't know exactly how, you know, these models were used. You know, obviously, like, you know, these things that you know, mistakes that happen in warfare are really, really terrible. Like, this is a really terrible thing to happen. We were willing to risk the future